Hello everyone, welcome back. So this week's focus is going to be on KNN. Apologies, that is me. Okay, KNN is your K nearest neighbor. And if you haven't subscribed yet, please don't forget to subscribe so that you know whenever I post a new video. And also, I would appreciate feedback. I want to know what's working, what's helping, and what's not helping so that I can improve on the not helping part and focus more on the helping part, okay? Okay, let's get started. So KNN is like trying to guess someone's favorite food based on what their friends like. Okay, so let's think about this example where, say, you have just gone to this new school and nobody really knows what your favorite lunch is there, but there's this really sweet cafeteria lady who wants to give you something that you might actually enjoy. And what she does is she checks who you hang out with. And your first day in this kindergarten, you've made 3 friends. Okay, you've made 3 friends. That's you, and these are your friends. And the cafeteria lady looks at the favorite food for 3 of your friends, which is, let's say, pizza, pizza, pizza. Those are ugly toppings. That's a really bad pizza. How do people draw pizza? Is that the right way? Okay, anyways, she looks at 3 of your friends and thinks, so your 3 closest friends love pizza. That means, according to her prediction, you must also love pizza. Okay, that's what you're gonna get. That's basically KNN algorithm for you in a very, very reduced, simplified version. Okay, so it guesses your label, which is favorite food, by looking at your nearest neighbors, who are your closest friends in the school that you've made on this first day. Okay, so let's let this example sink in. Okay, now we're gonna look at some core concepts. One thing I want to introduce is feature vector. So imagine a simple data set of animals with 2 features, let's say height and weight. Height and then weight. Height, let's say in centimeter, weight in, and this is just animal number or letter. Let's use letters. So animal A, B, C, D. Animal A has 30 centimeter height and 10 kg weight, so that's a cat. 3512 and is a cat. 7030 is a dog. 6528 and is also a dog. So each row becomes a vector that looks like this based on our features. So A becomes 3010, B becomes 3512, C becomes 7030, and then D becomes 6528. So now you get a new animal, which is, and you have no clue what this is, and you have to figure out what this animal type is. So what do? You try to find or compute the distance between X and existing animals. And here we're going to use what's called a Euclidean distance. The formula for this is very simple. Square root of the whole thing, x2 minus x1 whole square, y2 minus y1 whole square. Okay, this is your Euclidean distance. So let's figure out Euclidean distance for distance to A, B, C, D respect to X. Okay. So distance to A, 30, 10, and then we have 34, 11. So that would be 34 minus 30, 34 minus 30 whole square plus 11 minus 10, 11 minus 10 square, and then you square root the whole thing. Okay, so that's your distance to A. Okay, that would be 17. And if you do distance to B, that would be, again, we're looking at this. So that would be x2 is your 34, your x1 is 35 whole square, your y2 is 11 minus y1 is 12. That would be 2. So if I do the same thing, distance to C and distance to D, that would be 1657 and 1250. Okay, and if I have it correct in my notes, that should be 41, that should be roughly 40.7, and that should be 35.35. So we have all our Euclidean distances. So the nearest neighbor, and when we take K, we are trying to say how many nearest neighbors we're going to look at. Let's say for this case, let's keep our K as 3. That means we're going to look at 3 nearest neighbors. What are our 3 nearest neighbors with the distance here? The smallest obviously is this, and then the second smallest is this, and then your third smallest is your D. So this is your third smallest. So the top 3 are B, A, and D. So your top three are B, which is a cat, we know that, and then your A, which is also a cat, and then your D, which is a dog. So one thing we can do here, we're going to look at a different approach later, but for now we're keeping things simple. So how do we decide which prediction to choose? We vote. There are 2 cats, 1 dog. 2 cats wins, so we vote for cat. So predict cat for X. 34 centimeter height, and then 11 kg weight we're predicting is a cat. Okay, that's how it works. And then I know I said this is Euclidean distance. There's another way to calculate distance. For funsies, I'm going to show the formula. Although for our implementation from scratch, we'll likely just stick to Euclidean distance. But the Manhattan distance formula is Manhattan distance for x1 minus x2 plus y2, could be either way, x2 minus x1. That's your Manhattan distance. Okay, so for funsies, we're going to look at distance between B and X. Our B vector was 35, 12, and then our X vector was 34, 11, 34, 11. So Manhattan distance in that case would be just 34 minus 35 plus 11 minus 12, and that's just 1, and that's just 1 because we're taking absolute, so that would be 2. So that's another way of calculating distance, Manhattan distance, but yeah, we use Euclidean here, and this one's just Manhattan. The difference is we're taking absolute here, whereas here we were squaring it and then taking the square root of the whole thing. Okay, now let's also look at how prediction would work with KNN in regression examples, and I'm going to make it quick. So let's say we have a data set for predicting house prices. So it's just using size and then trying to predict price of the house. And say size is in square feet, square feet, and then price is in 100,000. So 1,000 would be 200K, is 220K, let's say. Sorry, that's an extra, okay. Is in 220K, and then let's say 1,500 is in 300K, and then your 1,700 is in 340K. Okay, so we now have a new house which is 1,200 square feet. So, and we're keeping K as 2. So what would be the distance? Let's calculate. So to 1,000, distance would be 1,200 minus 1,000, 200, and then to your 1,100 would just be 100. I'm just going to write it down because you know the formula already. That'll be 300, and then that would be 500. So which is the closest? Closest is your 100, and then it's 200. So here what we can do at this point is, since the closest are these and this, for your regression problem, we take these and we just give an average. So your predicted value would just be 220 plus 200 by 2, just taking a simple average. So you would predict it to be 210. Okay, so your predicted price is 210K for the house of 1,200 square feet using this approach. So yeah, that's another thing I wanted to mention. One thing that I want to touch on is feature scaling in this video. Feature scaling. Oh god, was I using a thin pen? I am so sorry, I just realized I was using a thin pen the whole time. I hope it was still visible. So for feature scaling, say your dataset has your feature X that ranges from 50 to 200, and then your feature Y that ranges from 5 to 50, and then now you just add a new feature, your feature Z, which ranges from 10,000 to, let's say, all the way to 100,000. So this is huge, right? This the huge value of Z now will dominate the distance. So KNN will only care about your Z unless you scale it, and there are different ways to scale it. You can while using Python in scalar, and you can use standard scalar or min-max scalar. We're going to look at some techniques for scaling because I think it's a good point to introduce this. So I'm going to create a video on scaling as part of this series, but I wanted you to keep that in mind as we're introducing the topic. The other thing I would say is, when you choose your K, try to choose odd K to avoid ties in classification. It makes life easier, because it just makes your life easier. So I like to choose odd Ks. And what else do I want to talk about? We can talk about weighted KNN here, because we didn't really look at it. We just looked at voting. So another approach, instead of voting that we did earlier, is to have weighted KNN. So we're taking the same example, and then we know the distances looked like this, and instead of each neighbor voting equally, we can assign weights such that maybe let's say weight I equals to 1 by d square. Okay, we assign the weight. So for b, that would be 1 by 1.41 square, 1 by 1 by 35.35 square. And then let me remove this. You know the weight, okay? Weight, I'm gonna write it here. Weight I equals to 1 by d squared. Okay. So the value for this would roughly be 0. It would be 0 0.5, would roughly be 0 0.06, and then 0 0.008. So this is cat, this is also cat, and this is dog. So the cat still has higher weighted vote. So still predict cat, but now the way we're thinking about it is just smarter than what we were doing earlier. So yeah, these are some of the core concepts. We will do a deep dive on some of the math, and we will then finally implement it from scratch in Python. Happy KNN!